Okay, guys. Hey, how do we solve this problem here? We've got a center of mass problem. So we've got a center of mass problem, like I said, center of mass, and we have an Earth-Moon problem. So what is the center of mass of the Earth and the Moon, and then the Earth, the Moon, and the Sun? And we're given a bunch of information that's a little bit hard to find in the question. We've got some masses of the Earth, et cetera, et cetera. There's all these numbers here that are going to become a roll. But ultimately, I'm going to get a blank page. Ultimately, what we've got is, well, let's just do it this way. I've got the Earth, let's do the Earth-Moon system. And we say that the moon is revolving around the Earth, which isn't true. They're revolving around each other, or actually around their center of mass. So this is the Earth, and this is the moon. And we have a distance between the Earth and the moon of 3.8 times 10 to the fifth. So what we've got is for the center of mass equation is the center of mass, and this is just going to the x direction, the xcm, the center of mass in the x plane, is going to be the distance, so x1, m1, I'll say that's the Earth, plus x2, m2, or m moon over your total mass. And that's how you solve the problem. So how do I do this? So I'm going to just take, that'll be 0 times the mass of the Earth, and I don't really care about that because that's going to be 0, plus, now I look up on my thing here, and it's 7.35 times 10 to the 24th times 3.8 times 10 to the fifth. Now, I flipped these around. This is the x right here, and this is the mass of the moon. And we divide by the total mass, and we are given the masses of the Earth and the moon, and the Earth is 6.0 times 10 to the 24th plus 7.35 times 10 to the 22nd. Now you're going to have a bunch of exponential ball game, but you get kind of a relatively simple number that's 4,600 kilometers. Now, what does that mean? That means that if this is the 0 point, the center of the Earth, then the center of mass is 4,600 kilometers from the center of mass. The center of the Earth, or the radius of the Earth, is about 6,000 kilometers. So it's actually inside of the Earth, but not at the center of the Earth. It's at the, it's like right here, right? It's, if this is the Earth, it's like that. So you're going to have a similar problem when you do the Earth, Sun, Moon problems. If I have the Sun, I'm going to flip it around compared to the image that's given here, right? You've got this image right here. I've got Sun, Earth, Moon right here. But what I want to do is I want to do the same problem. I'm going to put the Sun first, and then the Earth, and then the Moon. These are not drawn to scale. We'll make this the 0 point, and then this is 1.5 times 10 to the 8th. And this is going to be 1.5 times 10 to the 8th plus a very, very small amount, 3 times 10 to the fourth or something like that. 3 times 10 to the 5th. But when you're adding something to the 5th and the 8th, it's very, very small. So what you're going to find here, a very similar thing, is that when you find the center of mass, it's going to be well within the sun's radius. But it's just going to be 0 times the mass of the sun plus 1.5 times 10 to the 8th, that's the x, times the mass of the Earth, 6e24, plus 7.85 e22nd times 1.5 e8, all over the mass total. So I took all of the masses from the problem and added them all together, and I get a big fat number of 456 kilometers, which is very well inside. I don't know how, the sun is massive. 456 kilometers is not very far. So the whole Earth, Sun, Moon system is well within, close to the center of the sun, because it is so much more massive than the others.